So just a reminder, so chapter 22 is what we're going to cover today. Normally we cover that before chapter 23, but we already covered chapter 23. Homework is going to be due on both on Tuesday. So tell you what, let's just go ahead and open up a Excel. You guys can follow along with me here. Why didn't Excel open? Oh, it's just being really slow. Okay. All right, so let's pretend we're going to go through our same 7 steps that we always do. A researcher in Illinois finds that 219 of 500 students earn a 22 on the ACT math test. Does this represent that less than half of students in Illinois are prepared for college math? Use alpha equal 0.05. Okay, so Shire, what's step number 1? Find the numbers. So we have alpha equals 0.05. N equals 500. What is 219? That sounds like it's a useful number, right? 219 is, what did you say? I'm sorry, I can't hear. X. Just my bad hearing today. Is the 22 useful?
It would be X bar.
Is that X bar? What does 22 represent? No, 22 represents whether you pass the math test or not, right? Okay, we don't know that the X bar is 22. Maybe it is, maybe it isn't.
It says 22 doesn't mean pass.
22 means you're prepared for college math. 21 or less means you're not prepared. Okay?
Are you supposed to assume that?
Yeah. Okay, so I think we've got all the numbers, right? Step number 2 is what? Quantitative or categorical. And the answer is, we vote? Let's vote. Oh, but we are sharing. Who says it's quantitative?
Just can I clarify something really fast?
1, 2, no, we're going to just vote. 1, 2, 3, 4, 5, 6, 7. Who says it's categorical? 1, 2, 3, 4. Okay. Colin, you said quantitative, and the reason why was?
Because it's not, it's 22 on the ACT. We're looking at whether it's above or below a number as opposed to like a pass or fail.
It sounds like you mixed everything together in there.
I did. I totally did.
Okay, who else picked quantitative? Gage, did you pick quantitative?
I did, but I don't. I just picked it because I was thinking about it as quantitative, just because I know with categorical, it's more of a comparison thing. So I might be going more towards categorical.
So you're changing your mind?
I would have said quantitative if you hadn't said that 22 means pass, 21 means fail. But
And so now,
this many pass, this many fail. That's now qualitative. But before I just thought it was categorical.
Yeah.
Qualitative, categorical, same thing.
yeah.
But when before I just thought that they got 22, I thought, well, that is going to be quantitative because we're just looking at math scores. But I think it's categorical.
So you're going with categorical because it's pass-fail.
Yeah.
Okay? Do you see that, Brenda?
So,
Okay?
how are we supposed to know that?
How are we supposed to know that?
Because like reading that, I didn't.
Yeah, it didn't say that there.
Okay?
Yeah, it's not super clear, but I think the part where it asks, we're trying to figure out if students are familiar with college math.
We're trying to figure out if students are prepared for college math. Here's also another good clue here. This one is confusing. But what does this say? Less than half of students are prepared for college math. What does less than half mean? We're looking at a proportion, aren't we?
Yeah.
So that's a good clue, right? Okay. So that's why I didn't want to put X bar, but since you put it there, X bar, that's not really X bar. We didn't say that the mean of students were 22. 22 represents pass or fail.
Right.
Okay. And so that's not really X bar. Okay. Confusing, huh?
Yeah.
You gonna ace it, Natalie? Or Nicole, I mean?
I've actually been watching all the videos.
All right, good. Okay, so this is categorical. Do we all see that now? A good confusing one. Brenda?
If it was quantitative, we'd have X bar because we'd be looking at a mean.
If it was quantitative, we would be looking at X bar as a mean, yes. But that 22 is not X bar. It's background information to tell you how you decide pass or fail. Okay? So there to distract you. It worked for some of you, right? Okay? All right, step number 3 is what?
Null and alternative hypothesis.
Find the null and the alternative hypothesis. Okay? So let's pick on, did Jaylin leave? Oh, you just have your head down. Okay. I was like, you better not leave. All right. So, Jaylin, do you know what the null and the alternative hypothesis are?
Is the null, the top one, is that equal to?
I'm sorry, I can't hear today, so you got to speak up really loud.
Is it equal to 119 for the first one?
You said equal 219, is that what you said? Okay, who agrees with her?
For X.
X.
equals
Okay, so she wants an X equals 219. That's better. Without a letter, it would definitely be wrong. Okay. Who agrees with Jaylin that X equals 219 is the correct?
It'd be 22, wouldn't it?
No, it's 2219.
Who disagrees?
I'll straight up.
I disagree.
I can agree. Go
Okay,
through.
I need to pick up, so I always pick on Colin. I'm gonna pick on Ashley.
Wouldn't it be mu?
Mu? You're saying mu equals 219? Brenda, what do you think?
Categoricals aren't we comparing?
Categoricals aren't mu, are they?
We're comparing students. Oh, we're compared versus students.
P is a
We gotta share the wealth. Tanner, what do you think?
Well, I was thinking that it was P, but.
You were thinking what? P equals,
22.
P equals 22?
Why is that? Is it greater or less than, because if they get 22, they get less than 22, then they fail.
Okay,
No.
that 22, pretend it does not even exist. You guys, it's distracting way too many of you. And I know Colin wants to answer really badly, but I want to pick on somebody else. Brady,
Yes,
what is it?
P equals 219.
P equals 219?
Yeah.
Do you agree, Braden? No?
Throw me under the bus, then what is it?
What do we remember about the proportion? Can a proportion be greater than 1?
No.
No. So it can't be 219 because that's definitely greater than 1.
Take 219.
Take that, that's.
P equals 219 divided by 500. Who agrees with Braden? One. Who disagrees? Okay, Colin, I'm picking on you.
So I put P is equal to 0.5, And our alternative hypothesis is that P is less than 0.5.
Now, how did you arrive at that, Colin? He's been trying to answer me for a long time and I was ignoring him. Thank you for your patience.
Because it says does this represent that less than half of the students? So our goal is in regards to half of the college students. So we're saying our alternative is that yes, it is less than half, which means that our null hypothesis will be equal to half.
Amen.
Okay. Who's studying with Colin tonight? Only him? Okay, that was the correct answer and the correct reason. That was very good, Colin. Thank you for being patient. Okay? Do you see that now? Remember, the null hypothesis is often not stated directly in the problem, but the alternative almost always is, and that's your alternative hypothesis. Okay? And so if that's your alternative, okay, now, so if P is 0.5, we probably need a P hat, right? That might have been useful back here. What would P hat be? How did you get that? 219 divided by 500. Okay? That makes sense? Lindsay? Does now. All right. So now, step number 4.
Test.
Which test?
Which it would be.
And the choices are Z, a T, or a chi-square. Okay, should we vote? Everybody has to vote or you get it wrong. I'll take away your points today for your being here on your quiz if you don't answer. Okay, who thinks it's a Z? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it unanimous? Who thinks it's a T? Jalen, did you raise your hand? You think it's a T?
No, it's a Z.
You think it's a Z? Because I don't think you raised your hand there. Who thinks it's a chi-square? Okay, must be a Z. Which Z is it? Because we got more than one Z test, right? It's a 1 proportion Z test. Okay? Do you guys know the equation for the 1 proportion Z test? What is it?
P equals P hat minus T over the square root of P times Q divided by N.
Okay, that's great. Now, I got an email from Ashley a couple of days ago. Do you remember what the question was? Would you? Because I think that was a really good question that we could talk to everybody. And I already answered you, so hopefully you'll get the right answer.
Oh,
Okay?
Actually, I don't look.
You didn't look at your email. She just sent the email and never read the answer. That's okay. Don't look that if you haven't looked already.
Okay.
What was your question?
Was it about putting a certain equation on the?
Oh, there was that, and I didn't do that. What was the other question?
I asked about if 22 and 23 were going to be on the test, and I can't remember.
It was about standard deviation.
Oh yeah.
She asked. She said, "Why do we have all these standard deviation formulas?"
Oh, amen.
Essentially.
Hallelujah.
And she asked specifically. She said that I had that the standard deviation was the sum of xi
Yes, that was our question.
minus
So,
mu
yes,
squared over n minus 1, right?
That's all of
And then we had another one where the standard deviation equaled the square root of PQ divided by n. And why do we have all these equations? Besides to confuse you.
And just a slight question going off of that first one. I don't understand the sum part, because if you do the top equation, that's going to equal one number. How can you take the sum of one number? I'm so
Where is it the
confused.
sum of? Or what is the sum? What is the sum?
Sum of what?
Okay, this is a final exam question where I don't want to spend too much time on this, but why do we have these two equations? That's what I want to focus on. Are they the same equation? No, they're clearly not the same equation.
If
Different,
you
like,
have different data,
yeah.
like,
Yeah, what do I use this equation for?
Isn't that-
population standard deviation.
That's the
Yeah,
population standard
mu is
deviation.
Population.
But this is also the population standard deviation, right?
So I don't know.
So when do I use the first equation and when do I use the second? Yes, which one's which?
The top one is quantitative.
Top one's quantitative, the bottom one is categorical. Okay, so once again, why question number 2 matters. You guys all answer that and then ignore why that matters, okay? Why that matters, it helps you to pick the right test. That's why I ask it at step number 2. Okay? So does that make sense, Ashley? Okay, so yes, you need to know both. No, they are not the same equation. You use this one here for quantitative information. You use this one for categorical information. Okay? So I just wanted to make that clear. Now notice here, that's what the standard deviation is right there. That's the denominator essentially. Okay? All right. So now let's pick on Suzette. It's funny you guys put your heads down like, oh, he won't pick on me if I can't see. Okay? Suzette, can you help me plug in the numbers for that Z equation? And then I'll pick on Audrey because she didn't want to be picked badly.
Thank you, appreciate it.
I'm speaking very loud because I can't hear today.
So he had 0.4.
0.438 minus P, which is 0.5. Why is it 0.5? I can't hear you. I think both my ears are clogged.
Trying to find less than half of students.
Yes, it's the null hypothesis. That's what I was going for. Yes, okay. And the denominator is square root of 0.5 times 0.5 divided by 500. Okay, so we'll pretend that's a fraction. We'll get this divided by that. And what is that value I just found? Is that my p-value?
Can you go back over the equation for the denominator?
Okay, just a sec. Let me get the answer to this question first. What is this value? It's my z-score. It can't be my p-value. For one, it's negative. My p-value could never be negative. Number 2, it can't be less than 0, which I just said is negative. It can't be greater than 1 either, right? And even if that was a positive 2.77, that could not possibly be my p-value because it's got to be between what 2 values? Not negative 1. It's always positive. It's got to be between 0 and 1, right?
Yeah.
Okay. All right, Audrey, what is step number 6 or 5?
Find your p-value.
Find the p-value.
Can you go back and show the denominator for the last equation?
The denominator is right here. It's the square root of PQ divided by N.
Yeah, okay, divided by 500. Okay.
Yep.
Got it.
Okay. So, what do you think the p-value is?
That's when you look on your chart, or you do the equals, norm as this.
Equals norm as this. Now, by the way, well, we'll just do this for a second. Norm is just of that value, right? Now, how do you know whether you need to subtract that from 1? You draw a picture. You forgot to do that. Okay, let's draw our picture here. What's going on with our picture? Okay, tell me what to draw.
Bell curve.
Bell curve. What's the mean of my bell curve?
Zero.
0. What value did I get?
219. No, I lied. Negative 2.77.
It's a good thing we got the phone a friend thing going on. If only we could do that on tests, huh?
That's a great idea.
Negative 2.77. You know, I used to give group quizzes and they took it like 3 times longer because you had to talk about it.
I think we should still do it.
Yeah. All right, so do I want the area to the left or to the right? To the left. I want the black area, right?
Yeah.
Is that what Excel tells me?
No.
Yes, it is.
Yes.
Okay, we got to practice this more. You should know that just instantly. It tells me the area. Do I need to subtract this from 1? No. So I can take the value as is. Okay. So as we share this again. Okay. So do I need to double that or anything? Nope, that's actually the correct answer. Do we want to know how to do this on the chart? Does Olivia know how to do this on the chart? Olivia, do you know how to do this on the chart?
Are you asking me?
I am.
What are we on?
If you were looking up the p-value on the chart, do you know how to look? Do you know how to find that value, Olivia?
On the chart.
Huh?
What are you asking me?
Find the p-value on the chart. Do you know how? Because I'm getting the feeling you don't know how. Okay, so really this is a skill you should have learned about 3 weeks ago, okay? We're going to catch you up. Brady, how do we do this?
Okay.
Okay.
So you go down to -2 on
Negative
yeah,
2.7.
Yeah, -2.7, then you go over to 7.
7, right?
And then you go down, that should be.
And that's the value right there.
Yeah.
Okay? Do you know how to do that now, Olivia?
Yeah.
Okay? So I got 0.0028. So depending on whether you use the chart, that's just rounded, right? Okay? So now, step number 6 is what, Gage?
Write your statement, isn't it?
No.
Oh, yeah, rejector.
Oh, did you use the A word?
Yes.
You need to go rinse your mouth out.
Except, you use except. It's rejector, you're not rejecting.
Reject or not? He's like, what A word? What A word did I use? I didn't swear.
Yeah, no, I ain't.
Okay, and so the answer is reject or do not reject.
So below, so it would be reject.
You sure?
Below 0.5?
Yes.
Are you sure?
This is what I.
Yes.
Are you really sure?
Yes.
Okay, good.
I'll put that.
You're getting more sure as we go. That's good. Okay, and so, Lindsay, conclusion is
That there is evidence
there is evidence
that less
that less than
than
half
of Illinois
students
are
prepared for college math. Okay? Yes.
Okay, I have a question about something we did a steps back. For the denominator and the z-score, could you show us something with it?
The denominator right here, this denominator,
Yeah.
what is Q?
Q is 1 minus.
1 minus P, right? What's P?
Oh, so that's why it was the same as P. Okay.
That's why it was the same as P in this case. Okay, because P was 0.5. Okay? Any other questions? Okay?
Starting to make sense.
Now, let me ask you another question. What if I said find a 95% confidence interval?
Quick question based off of the
Okay.
drawing. So that was, we drew that in order to know we needed to do 1 minus the z-score, right? If the question had been, does this represent that more than half the students are prepared for the college math, we would have done 1 minus z-score, right?
That's correct.
Okay.
Yeah. Okay. All right, how would we find, do you guys know the formula for finding a one proportion confidence interval?
So it's z-score, so.
I probably didn't put that on there. Here, we're gonna do this again.
P hat plus or minus z sub alpha over 2 times square root.
There we go. I'll write it on the board really quick.
Where would be P hat?
So Z,
I was gonna say this first.
no, your confidence interval equals P hat plus or minus Z sub alpha over 2 times the square root of PQ divided by N. Okay? Yes, Brady.
So on the equation sheet, it says P hat 1 minus P hat 2.
Okay, that's for two proportions.
Okay. Oh, okay, I see it now, I see it.
Right. Okay, yes.
Sorry, that says C sub alpha, and then what?
I can't hear
Oh,
you.
over 2, is it alpha over 2?
Alpha divided by 2, yes, that's correct. Okay, now let me ask you a question. This bell curve represents the hypothesis test, right? Is a confidence interval one or two-tailed? It's two-tailed, okay? So the reality is, okay, if I'm doing a two-tailed hypothesis test, excuse me, if I'm doing a two-tailed confidence interval, what is the mean of my confidence interval? Okay, this represents the hypothesis test, but I'm going to be doing a two-tailed confidence interval, right? So you can see that these are measuring different things. You see that? Okay. If I'm doing a confidence, so this is my hypothesis test, this is my confidence interval, okay? So these may or may not agree, okay? Because this is one-tailed, this is two-tailed, so they might not agree. They might agree, but they might not agree, okay? This is what you need to do on your final project. Especially if you're doing a one-tailed versus a two-tailed, there is a chance that they may not agree. This is the case. We're going to find out if my confidence interval agrees with my hypothesis test. The confidence interval is going to have a different picture. What is the mean of my confidence interval? Mean might not be the best word to use. But what should this value be if I'm doing a confidence interval? It's not, well, this is standardized, right?
Yes.
This is not going to be standardized.
So it should be in the middle of your number.
Okay, yeah, your mean is going to be in the middle. What is this value? It's not going to be 0 anymore.
Mark or the whole y section?
The mark.
Okay, I thought the y section would be like, let's say 90%, and so you come in.
Okay, so I see what you're saying. We're using the 95% confidence interval, right? So that's true. We've got alpha over 2 here, and we've got alpha over 2 here. But I still want to know, what is that value right there?
At that point, is that not 50?
Is it 50?
Or would it be 47.5? Because that's the middle of 95.
Okay. We did a survey, right? Did we get 50% in our survey?
No.
No, what percent did we get?
Like 40%.
Yeah, 43.8%, right? This is a p hat. This represents p hat. P hat equals 0.438. Okay. Now the question is, if we go out here, is 50% going to be in obviously it's going to be to the right, it's not going to be the left, correct? Right. Is 50% going to be within this value here? That's what we're trying to find out. Okay? So the mean of your confidence interval is p hat right here. And we're going to go approximately, remember with the 68, 95, 99 rule, how far out do we go for 95% confidence? 2 standard deviations, right? Now, it's not exactly 2 standard deviations. It's 1.96, right? So if I were to convert this to a standard normal distribution with a mean of 0, I'm going to go 1.96 standard deviations out. Now the question is, what value does that equal here? Is 50%, and the question is 50% in there or not?
If 50% is in the white.
If 50% is in the white, is there a significant difference between 43 and 50? No. If 50% is in the black, is there a significant difference? Yes, there is. Does that make sense? Okay, that's what you guys need to be doing on your final projects. Okay, yes.
Okay, did you plug the numbers into that equation, p hat plus or minus d alpha?
So p hat is 0.438 plus or minus.
Would it be 0.5 over 2?
No,
Would you need to do?
1.96. Remember where did I get the 1.96 from?
Oh, you got that from your chart.
Get that from your chart, right? Let's
Yep.
let's show that really quickly. Okay. So when we're looking at our chart here, okay, here's my confidence level. 1.96 is right there. 95% confidence. Okay. So that's where I get the 1.96. Now, let's go back here. Times the square root of, what's p? 0.5 times 0.5 divided by 500. Okay, let's plug that in.
Is the square root over 500?
Yes, yeah.
Okay, so everything's over the square root.
Everything's underneath the square root.
And then why is it 0.5 times 0.5?
Why is it 0.5 times 0.5?
Because Q is 1 minus 0.5, which is 0.5.
Remember, we were asking if half of your students are prepared. P is 0.5.
Okay.
So Q is 1 minus P, which.
Oh, it is, okay.
Okay. Okay, so as we do our confidence interval, I've got my lower, I got my upper, equals P hat, which is 0.438, minus 1.96 times the square root of 0.5 times 0.5 divided by 500. Okay. Oh, I did something wrong. How do I know the answer is wrong immediately? No, it could be negative.
Oh, because since we're working with proportions.
If we're working with proportions, would I get a 21?
No.
No. Okay, I put a times instead of a divide there. Let's try divide there. Now I've got 0.39. I change that minus to a plus. Okay, now I want you to write 2 different confidence statements for this. We'll write the one that I trained you on originally, but that's not what I want you to use on your final project, okay? What's the one I trained on you originally? Who haven't I picked on? Tanner, I haven't picked on you.
The original confidence interval. So we're 95% confident that is it the student score would be between
That the what?
a student score or
That the student score is between
the lower and upper ends.
0.394 and 0.481. Is that a correct statement? Who agrees with Tanner? Who disagrees with Tanner? Okay, some people didn't vote. Okay. Brady, why do you disagree?
Don't you need to say that we are 95% confident that students that score less is less than 0.5 or between 0.394 and then 0.48?
Are we measuring scores? No.
We're measuring the percentage.
The proportion of Illinois students, right? So it's not the student score. What is it?
95% confident that the
proportion of students in Illinois prepared for college math is between 39 and 48%. Okay? Now, here's what I want you to do on your final project. Okay? In fact, let's go back to this question. Does this represent that less than half of students are prepared for college math? I want you to only look at the confidence interval to answer that question. Yes, less than half of students are prepared for college math because, why? 50% is not in my confidence interval. Do you see that? Because 50% is outside this interval, right?
Yeah, okay.
Okay, so we're 95% confident that the proportion is between 40 and 48% roughly, right?
Close.
So it's close, but it's less than 50.
Okay.
Okay, let's pretend that I got, instead of 48%, I got 0.523. Okay, let's pretend that was my answer. Does that mean that less than half of students are prepared?
No.
No. There is not a significant difference. Okay, now just for fun, I'm going to leave this wrong number here. So in this case here, I said that less than half of students were prepared, and I said no, there is not evidence that half of students are prepared. Okay. Does my hypothesis test conclusion, does that match my confidence interval conclusion? No, they disagree. Okay, does that make sense? This says less than half are prepared. This says no, not less than half are prepared. So they disagree.
So what is that?
Okay, so well, it could be two things. Either number one, you made a mistake, and clearly we did because I changed that number. Or number two, it could be because you're doing a one-tailed test versus a two-tailed confidence interval. That could be the difference.
And so if let's say they disagree and we check everything and everything is correct, then we just leave it as is?
Yeah, you leave it as is. They don't agree. And there are rare cases, but they usually are rare, where they will disagree.
So if they disagree, we should check.
It's usually because your confidence interval is like right on the edge of your hypothesis test.
And have you had people that do the presentations?
So typically, let me just say this. I'm really trying to teach you guys better because almost every time that I do these final projects, people will do one of these correct. And then they will say, and they agree, and they don't agree. Or they will say they don't agree when they agree. Okay? So you got to really check your math. Remember, you've got most of you have 4 or 5 people in your group, don't you? Can't remember. But, you know, you always say we want group work. This is your group test. Okay? Now, I will tell you that there was one case last semester where I had a group. I don't really like this, but I supported her in this decision. She said, all my group thinks we're supposed to do it this way, and I disagree, and I think it's this way. And so when they did the presentation, the group said, this is what we think. And then she said, and I disagree with my group, and this is what I think. Okay? She was right. Okay? Normally, I just say, what your group says is what your group says. She was right, the group was wrong. I gave her more points than I did the rest of the group. Okay? So make sure that you listen to your group, and you need to come to a consensus, and you need to check each other's work, okay? Because the rest of the group got a terrible score. She did better. But normally, it's your group is your group, and I want you to agree, okay? And I want you to listen to people, and just because 3 people say are doing it wrong, don't say it's right, okay? All right. Do you feel good about that? Okay. Do we want to do one more? We got 20 minutes. If we hurry, we could do 2 more.
Wait, have we?
Let's take
is
our
this
time.
Have we gone through chapter 22 and 23?
Today, we've only done chapter 22. 23, we've already done. I would like to do 1 more in 22, and I'd like to do 1 in 23 so that we can see the difference.
Do you explain the difference between them?
Should we just do one from 22?
Okay, so let me ask you this question. Okay? You guys are comparing your survey results about whether Donald Trump should have a primary challenger, right? Okay? You are comparing that to a known survey. Okay? Is that going to be a 1 proportion test, or is it going to be a 2 proportion test? Let's vote. Who says it's a 1 proportion test? Who says it's a 2 proportion test? Okay. This one you could argue a couple of different ways, but let me just say it this way. Do you think your survey is as good, is going to be as quality as the national survey?
No.
Okay. Who do you think is probably more right, you or them? Them. Okay. We're going to assume that the survey is the population. So it's going to be, so you should do a 1 proportion test. Okay. Now, here's what might be interesting though. Actually, maybe we should do this. This will be good. How many people, how many respondents do you guys have for that survey?
What, like 100?
Are we wanting
The phone book, you're only going to have 30, but if you combine all of them together, all of the surveys together, okay, how many are you going to have total, would you guess? I hope it's more than 100.
It is.
You're looking at, you're almost close
Okay,
to
so here's what I'm going to change this project just slightly. All it's going to do, here's what we're going to do, okay? I want you to do a 1 proportion test that compares your survey when you combine everything, all of the different methods, okay? I want you to combine that for a 1 proportion test, okay? To the, was it 538 that I picked? I can't remember, whatever the website was. I also want you to do a 2 proportion test, okay? And I want you to compare your own results to yourselves, okay? You can either choose, is there a difference between men and women? Or you could also say, is there a difference between Republicans and Democrats? I will let you pick. I have a feeling you're not going to get very many Democrats in Utah, though, right? So maybe we should just go with the men and the women. Is there a difference in opinion among the men and the women? That'll be a 2 proportion test, okay? Now, let me make sure that we're clear on this. Let's pull up the directions here. Are we sharing, by the way?
So do we have to go back and survey people again? Because we've already done all our
Lots of
surveys.
people did.
No, you don't have to resurvey anybody.
How do they know if
How do we
they're men
figure
or
out
women? I mean, our group, for everything we
If you
did-
didn't keep track of them, if they're man or women, that's going to be a problem. I always told you to keep track of gender.
But
If you didn't, that's a bad mistake.
yeah, we did. So we did.
I hate this thing.
But we did that just because we did it extra.
If you didn't do that, did you keep track of age?
If they want it.
You should always keep track of age. How are you going to make a histogram? I hate this thing. Because you could compare old people versus young people, and I'll let you decide where you want to do that. Okay? All right. project. Okay, so let's make sure we're super clear on this. In fact, maybe I will update this a little bit, okay? You're using 5 data collection methods, okay? You're using a simple random sample, using a phone book, you're using voluntary response, social media, you're using a systematic sample, you're using a cluster sample, you're using a stratified sample, okay? So you should have 5 confidence intervals and 5 hypothesis tests for each one of those methods. You're comparing each one of those methods using a 1 sample proportion test to the national poll that I gave you, which I said was the Hill. We're using this Hill, the Hill website. That's what we're using. You're comparing each one of these 5 to the Hill, okay? Now, I'm going to add this on here because I think this is good. So, here, I'll put a 2 here. Let's just change it here. Do a 1 sample proportion hypothesis test and confidence interval for each of the 5 collection methods. Okay? Then I want you to combine the data to do an overall hypothesis test, an overall 1 sample proportion hypothesis test and confidence interval to the Hill website. Then I want you to combine the data and compare a 2 proportion test between either men and women, Republicans versus Democrats, prominent / independents, because some people don't want to be called that, they'll be called independents, or old versus young, okay? And what I would recommend to you is when you're doing old versus young, get about half in each. It doesn't have to be exactly half, but figure out where the, let's say the mean age is, or the median. Let's pick the median. The median age, and then, let's say the median age is 35. 35 and under is in one group, and 36 and over is in the other. Okay? Does that make sense? Okay. So you're going to be doing how many? We've got 5 confidence intervals, 6, 7. You should have 7 hypothesis tests and 7 confidence intervals. Is this good practice for the final or what? For your final project, okay? Then you're going to have an 8th with the 5-pound bag of potatoes or the school zone. Is anybody doing the school zone? Oh, good. I'm glad, because last year that was what almost everybody did, and I don't think anybody's doing it this year. That's fine. Then you're going to do a 9th one with the color distribution on the candy.
Are we only doing hypothesis tests? You don't want any other?
Well, I want frequency distribution tables in there. I want bar graphs. I want pie graphs where they apply. You were supposed to collect the age data, so you probably should have a histogram on the age data.
You did not say that.
Yeah, you haven't said any of this, like when you first said it at the beginning of the semester.
Yeah. If you want us to collect that, you probably should have put it on there or told us that.
I said,
The age, by the way.
Or the,
okay, every survey, you're always supposed to collect gender and age. I know I talked about that. We'll go back and watch the video. Okay? Okay.
This video where you said,
So did nobody collect, who collected age? Hallelujah. 2 people. Who did not collect age? Everybody else? Well,
We collected gender, but that was it.
And we did that, we didn't even do that because we thought we had to, we were just kidding.
yeah, because I remember specifically you mentioned in class, something that might be cool is if you collect gender and then you could compare those at the end. But you added that as a side thought, like you might do that just for fun. And
so you were like,
sure,
oh, I'm going to do the bare minimum.
And so, no, and so
No,
we,
we
and
went
so
the
we
extra
said,
mile.
we said, oh, cool, that would be cool. And so we did collect male and female to just compare them, but I don't remember anything
We
about.
just went off with what's on the Word document.
Yeah, and we had to get IRB approval and we like wrote out everything that we were going to collect. So did they write that they were collecting age? Because if that's not on the form, then does it even?
It's just a survey. They're not that picky.
Right. So we did.
Okay, well, you're going to miss your histogram then. That's not good. Appropriate graphs. Okay?
We can't.
The graph histogram is not appropriate if we don't have that, so.
You're correct. If you don't have it, but it's,
I was going off.
Well, we didn't know that it was even on there, like, we didn't know, so how can you like put it on, like, how can you grade it against us when we didn't even know?
okay, well then go collect some new data then. Okay, you had all semester, so go collect some new data.
Now we don't have all semester.
We had all semester not knowing that we were supposed to collect that.
Okay, well you need to collect it. So we got till the end of class to collect it, so.
How did you guys that did it, why did you collect it? Did you see that in the instruction? No, I talked to
All right, so let's go over another hypothesis test. Which one do you want to do? Do you want to do another 1 or do you want to do a 2? Or do you want to leave because you're all mad?
Yeah,
I'm a little deflated.
let's keep talking about this.
Can we do like a
I don't see how this is
hypothetical
fair.
sample of our project using a one proportion test, like with fake data? Kind of show us how.
Well, it works the same way as you do any other
I know,
thing.
but visually seeing it helps me a lot.
Okay. Let me see here. Because what we just did, it works out perfectly. Let me try this one. Let's do a 1 proportion, okay? All right, I like this one because it's not going to be 50%. Prevnar vaccine is administered to 710 randomly selected infants between 12 to 15 months of age. A little big. 121 experienced loss of appetite as a side effect. Is there significant evidence that loss of appetite is different from 0.125, use alpha equal 0.01. Okay? All right, so what one I picked on? Landon, it must be your turn. Where do we start here?
Let's get our numbers. And it's
Get the numbers.
7120.
Oh, except for it's supposed to be 710.
And it's 710.
And equals 710.
X is 121.
X equals 121.
Alpha is 0.01.
Alpha equals 0.01.
That's we could get that.
P hat
121 divided by 7.
121 divided by 710.
And that's probably it.
Okay?
Categorical
Categorical or quantitative?
it is. Okay, it's gonna be categorical.
Categorical. Step number 3, Ashley.
Let's see. Oh, the alternative hypothesis.
No. And the alternative hypothesis. So P hat, is that what you said? Okay, who agrees with her? Nobody? Who disagrees with her?
I agree.
Only one person? Only one person has a potential to get this right or wrong?
So I think P hat would be 0.135.
You think P hat equals 0.135?
It might be
Who agrees? Whoops, what happened there? Who agrees with Lindsay? 1, 2, 3, 4. Who disagrees? Y'all should have disagreed, although she's closer. What are the rules? P, not P hat.
Oh, I even thought to say that, but and then you just were typing P hat, so I thought you didn't matter.
P, why is it P and not P hat? Because we're looking at population, not statistic. Parameters and statistics. Remember, we've got to still make sure we know the differences. Okay? All right. So, Lindsay, I do want you to know that if you follow these steps, this is exactly like your project. Okay? Step number 4.
Wait, our project is alpha gonna be 0.05.
You can pick it whatever, you're in charge.
Our own alpha?
Yeah. You always, the experimenter always gets to pick their own alpha.
How does that work then?
What do you mean, how does it work?
What if we get our result, our p-value, and what if we picked an alpha that's lower than it, but then someone else picked an alpha that was higher than it?
So what?
Rejecting something?
They can do what they want. It's their experiment.
I'm just gonna use 0.05.
Yeah, I'd recommend that. That's probably good. All right, step number 4 is what, Gage? Type of test? Is it a Z, a T, or a chi-square? Braden, what do you think?
The proportion Z.
1 proportion Z. He goes straight for the jugular. He's like, don't mess around. I'm going straight there. Who agrees with Braden? 1, 2, 3, 4, 5. Who disagrees? Okay, 5 people got it right. The rest of you got it wrong. Hey, what's the equation? We gotta hurry. We're gonna run out of time.
V equals P hat.
P hat minus P square root of PQ divided by N. Okay? Brenda, can you take it away?
P hat 0.170423 minus 0.135 divided by 0.135 times 1 minus 0.135 over 710.
Okay, we'll take the numerator, divide by the denominator. We get 2.76. What's next, Shire? And the p-value. To the computer. I can't hear you. Norm as dist. Is that correct? What step did she forget to do? What would Rick do? Draw a picture. Okay. Here's what happened. Draw our picture. We got to do this quickly. We got 0 here. I got a value of 2.76. What area do I want? To the right or to the left? I want it to the right. What did she find? Area to the left. Okay. And I want it to be two-tailed. So in this case, I need to not only do 1 minus, but then I get to double it. Okay, that's the correct value there. Okay, step number 6. What's that? Reject the null. Step number 7. There is evidence. Infants. What?
Infants have loss of appetite as a side effect.
Loss of appetite. Okay. All right. So we will review on Tuesday. See you all then. So remember, homework on 22 and 23 is due, and the quiz will be on both. Okay? See y'all tomorrow. Or Tuesday, whatever.